so I've just got one more example, and then we got a bunch of practice problems here. It just takes practice, and you have to do the practice. Watching me isn't going to help that much. So, so let's take a look at one more example, this one involving trig functions. All right, so I've got the indefinite integral, which is just the antiderivative of sine of x plus 3 times cosine of 5x. Now I have the sum of two functions here, so I can actually break this into the sum of antiderivatives, right? So I can make this into the antiderivative of sine of x dx plus 3, okay, this time I'm bringing the constant out front, cosine of 5x dx. Okay, so I'm going to kind of just do the derivative of each part. All right, so what is the antiderivative of sine of x? Well, I know that the derivative of sine of x is cosine. Derivative of cosine is negative sine. So cosine of x, if I took the derivative of that, I would get negative sine of x. But if I take the derivative of negative cosine of x, then I get the negative sign, right? The negative of the negative sign. So the antiderivative of sine of x is the negative cosine of x. Or you could look back at the table. All right, and now we're going to do the integral of this cosine function. Now the integral of cosine is sine, right? So so I've got this constant 3, and I also have this 5x. If you look back at the table, so if you look back at this table, all right, you can see that when we take the integral of cosine of kx, we get 1 over k sine of kx plus c. All right, so that means we're going to have a 1/5, right? So we're going to have times 1/5 sine of 5x plus c. Okay, so that's pretty, I could clean this up a little bit if I want to, just by making that 3 times 1/5 into 3/5. But otherwise, it's pretty much fine as it is. Don't forget your plus c, though, because the solution is not unique unless we have some sort of way to anchor one point of it. All right, so there's a bunch of practice problems. That's what we're going to do in class today. So I'm going to leave that to you, and I will see you in class.